Now, the other thing that happens with DeepSeek is this chain of reasoning concept, where you're kind of saying, rather than you kind of, in an LLM, it's kind of like you're just spewing out text. It feels like it's very unplanned. Well, in the kind of chain of reasoning, chain of thought kind of approach, what is typically happening there is that the LLM will produce for itself a plan. I'm going to try and do this, then that, then that. If this doesn't work, I'll do that. If this, it builds up this kind of often tree of possible things to do, and then it goes and executes on the plan. Now, current technology, the executing on that plan, the plan is pretty much predefined. And you can see in the kind of chain of reasoning of DeepSeek, for example, you can see it say, well, I'm going to try this. Oops, that didn't work. Let me now try that. It already had that plan. It wasn't making up that plan on the fly based on the things it saw happening. But I think the thing that's coming is being able to insert, for example, our computational language in the middle of that, so that when it tries a branch, it can then try that with our computational language and then know, and then invent a new branch to try. Now, in general, when you have this kind of chain of reasoning, you're expecting that the final answer you get is the result of many steps. So one of the things that can go wrong is if one step builds on another, builds on another, builds on another, which is something that's happening in chain of reasoning much more than happens in an essay. If you're writing an essay and you write something and you have a sentence that's kind of wonky, you can recover very easily by having another sentence that is not so wonky afterwards. And nobody's going to, the essay is not going to sort of fall apart. On the other hand, if you have something where you're sort of building a chain of a tower of reasoning, and one of the bricks in your tower is made of mud, then the unbaked mud, then then the tower is liable to topple over. And so it becomes much more important when you build this kind of chain of reasoning, it becomes much more important to make sure that every link in the chain is something solid. And that's a place where our technology and computational language is really, really critical to being able to make those solid bricks, so to speak, to make something that is precise and computational, where you know that when you build on top of it, you're building on something solid, and your tower is not going to fall over. So something that, well, we're experimenting with is really forcing a chain of reasoning model to have solidified itself as a computational language thing before it goes on to the next step. And we're in the interesting position of having sort of the unique computational language that really describes the world computationally. I mean, we're not just a programming language where you're describing things inside a computer. We're dealing with things where we can describe cities and foods and all this kind of thing. We have a computational representation of those things that allows one to sort of do this kind of solid building up of computational things.